The Azores archipelago is located in the North Atlantic Ocean along the mid-Atlantic ridge. The islands are 1,500 kilometers from mainland Portugal and 3,900 kilometers from North America. Pico Island is the second largest of 9 islands and is located in what is called the Central Group. It is named for the mountain that dominates the landscape. Pico Mountain is an inactive stratovolcano that last erupted in the 1700s. It is the highest point in Portugal with an elevation of 2,351 meters. The research station sits in the caldera of the mountain at an elevation of 2,225 meters. To climb the mountain, sturdy, broken-in boots are a must, along with strong trekking poles. The ground is rocky and uneven, so those two pieces of equipment are vital. Enough water and food must be carried in your backpack for both the climb up and back down. The weather can change quickly, so layers of clothing with rain gear are crucial.
Okay, so one of the major new aspects to our project is to sample aerosol in this super clean environment here in the free troposphere to understand something about the overall aging of the aerosol. What does its composition look like? Can we see signatures of maybe cloud processing and whatnot? And so in order to do that, we need to collect as much aerosol as possible. So we've got these 4 different samplers. Each one of them will run for 24 hours, so one day. And by having 4 of them, it minimizes a little bit the climbing up the mountain, up and down. We can come every 4 days and change 4 sample sets, which is really nice. And as you might have seen, the hike is fairly strenuous, so it's not good to hike for 3 hours every day. But anyway, as you might be able to see over here, we're above the cloud layer, and so the air up here isn't necessarily as well mixed, but typically if we do see aerosol particles here, they're coming from a long range. So a big wildfire in Canada or somewhere out in the west, there's a lot of heat that's generated from those kinds of wildfires, and so it can propel the aerosol directly up into what we call the free troposphere, so above the first cloud layer. And then it kind of stays here and it has a longer residence time because there's less ozone and other oxidants in the free troposphere. And so it transports across continents. So we can see aerosol movement, from Asia to North America, and now we can see aerosol movement from North America towards Europe. And so by collecting a 24-hour sample, which is basically 1 cubic meter per minute times 60 minutes times 24 hours, we get a pretty good amount of carbon so that we can do some chemical analyses with that, which is really important. I'm going to show you what the sampling looks like here in just a minute, but we'll probably see that we won't really see very much color associated with the aerosol today because the last few days have been pretty clear. When we see subtle brown layers in the atmosphere, sometimes we actually see brown color on the actual filters that we're using to collect the aerosol. So that's a good sign because that means that it's working. So, yeah, so let's take a look over here.